Question number 8. This question is about fuel cells. The methanol-oxygen fuel cells, the overreaction is this whole overreaction. EMF of the cell is 1.20 volts. At the positive electrode, oxygen reacts with hydrogen ions to form water. Give half equation for this reaction. So you got oxygen, hydrogen, gives you water, then you balance the equation. You go 4H plus, and then 4 electrons to balance H plus. Then, at the negative electrode, methanol reacts with water to produce carbon dioxide and hydrogen ions. Give half equation for this reaction. So you got methanol plus water, gives you carbon dioxide and hydrogen ions in here. Then you just balance, you got 6 hydrogens there, you count them, there's 6 there, and then you 6 electrons to balance it out. Next question. The standard electrode potential of the CO2 CH3OH, which is this one here, is 0.03. Calculate the standard electrode potential for the O2 H2O, which is this one here. So that one is the most positive, that one is most negative. So remember, E cell is the most positive minus most negative. So you replace E 1.2 equals to most positive, that's the one you need to find out, minus most negative. So if you rearrange this equation, it gives you 1.23 volts. State why a fuel cell does not need to be electrically recharged, because the reactants are supplied continuously. Suggest one advantage of using methanol rather than hydrogen in a fuel cell for using cars, because methanol is a liquid, and so it can be stored easily and transported easily compared to hydrogen, which is a gas. Question 9. This is a question about flight, TOF, mass spectrometry. Give the equation including state symbols of formation of Cr plus ions from Cr, atoms by electron impact. So you go strontium gas, plus electron, then you got strontium plus, so you knocked 1 electron off, so it becomes a positive charge, then you got 2 electrons altogether. 9.2, a sample strontium, this is a calculation, which I already explained how to do that before in my other videos. A sample strontium is analyzed by TOF, mass spectrometry. The sample is ionized using electron impact. The ions are accelerated to have a kinetic energy of this, so you know the kinetic energy. Ion takes 9.47 times 10 minus 4 seconds to travel along the 95 centimeters flight tube. So you need 2 equations. So you got the kinetic energy equation and you got the velocity equation. V equals distance divided by time. Mass is in kilograms, velocity is speed, V is speed, meters per second. Use information given to deduce the mass number of this ion. So we want to know the mass number. Avogadro's constant is this one here. So you start by using V, you got the distance divided by time, gives you V. Once you have V, you rearrange this equation to find mass. So this is the equation to find mass. So you go mass equals 2Ke. So I'll bring this up a bit. 2Ke divided by V2. So mass ends up being 1.396 times 10 minus 25 kilograms. Then you have to change that into grams, okay? So kilograms to grams multiplied by 1,000, which gives you, so you change kilograms into grams. It becomes from multiplied by 1,000 and gives you minus 10 to the minus 22 instead. So the mass of my ion is 1.396 times 10 to the minus 22 grams. So MR is moles equals mass over molar mass. So MR is going to be moles times, so we know the mole, and you got the mass. This is the mass of the ion. So you multiply by the Avogadro's constant. This is 1 mole is Avogadro's constant. It gives you 84.04 gram per moles minus 1. Okay, you don't have to put the unit, but that's the mass number, 84.04. Hopefully it makes sense. If you don't understand this very well, I made a special video how to work out these questions. 9.3. I explain how ions are detected at TOF mass spectrometer. State how the relative abundance of the ions is determined. So how ions are detected? Ions hit a detector and each ion gains an electron, generating a current. How relative abundance is determined? Current is proportional to abundance. Okay? So now these things you have to know, you have to learn them. So you got 9.4. A sample of strontium contains 3 isotopes, strontium-86, strontium-87, strontium-88. 82% of the sample is strontium-88. The other isotopes is 1:2 ratio of strontium-86, 1:2, 87. Give an answer to deduce relative atomic mass of the sample. Give your answer to 1 decimal place. So you got 100% minus 82 gives you 18%. So 18%, so it says here 87 is a ratio 2. Okay, so strontium-87 is 2 times 18 divided by 3 because there's 3 lots in there, gives you 12%. So the strontium abundance 87 is 12%. So once you know the strontium abundance, you can work out relative atomic mass. So you got 82 times 88, which is the first one, 12 times 87, and whatever's left over is 6 times 86 divided by 100. Gives you 87.8 relative atomic mass of strontium of the sample. Right. Electrospace ionization is used instead of electron impact ionization of a protein in a mass spectrometry experiment. It suggests why. Because the protein ions does not break up like normal other ions into fragments. Okay, so that's the reason they use a different method. Question 10 is about pHs and pH range some indicators, about weak acids. So you got different indicators, identify the indicator that's most suitable for use in titration between propanoic acid and sodium hydroxide. So this is the indicator used for a weak acid and a strong base, which is thymo blue. This is the area where they get the indicator seen. So you need to learn those two. Give the expression for the acid association constant for propanoic acid. So Ka equals H plus. So you need to know that CH3, CH2, COH breaks down into those two. So if you go like this, dissociates into this CH3, sorry, CH2, COOH, dissociates into H plus CH3, CH2, COO minus, okay? Then you put that into an expression of Ka. Then calculate the pH of 0.1 mole per dm cube propanoic acid solution. Give your answer 2 decimal places. For propanoic acid is pKa is 4.87, so you start by putting Ka. So Ka is 10 to the minus pKa, so it's going to be 10 to the minus 4.87, which gives you 1.35 times 10 minus 5, okay? Then you have this equation of weak acid, so you know that you rearrange of putting H plus squared here, divided by that, so you find H plus first. You know that H plus squared is Ka times that, so we know the Ka, which gives you here, times 0.1, which is the concentration of your acid. And then you work out the H plus by taking the root of the whole thing. Then it gives you 1.16 times 10 minus 3 mole per dm cube. Okay? And then you got then you got pH equals minus log 10 of the whole thing, which gives you 2.94 pH. So the pH is 2.94 for that one there. Thank you. Right, let's do 10.4. For butanoic acid, you got Ka 1.51 times 10 minus 5. So you got 20 centimeters cube of 0.1 sodium hydroxide solution added to 25 centimeters of 0.1 butanoic acid solution. Calculate pH of solution form. So initial amount of butanoic acid is 25 times 0.1, okay, divided by 1000, which gives you that value there, 2.5 times 10 minus 3 mole. Initial amount of sodium hydroxide, you have 20 times 0.1 divided by 1000, which gives you 2 times 10 minus 3 moles. The final amount of acid is going to be the initial minus whatever is being used up, which gives you 5 times 10 minus 4 moles. Okay, so that one, take away that one because it's been reacted. Then this is your acid value there. Then you got H plus is Ka times HA to H minus, which is, this is the equation for the buffer solutions. So H plus value, we work out H plus value. So you got Ka, we know 1.51, which is there on the top of the table here. And then times, if you put an equation, remember divided by volume there. It's because the volumes cancel each other out. So you don't have to put the volume there anymore because this is part of the concentration divided volume gives you the, no, that's, that one is the moles divided by volume gives you concentration. So because the volume is the same, we can cancel out. So therefore you just can ignore that. So then it gives you 1.51 times 10 minus 5 times 5 times 10 minus 4 divided by 2 times 10 minus 3, which gives you 3.775 times 10 minus 6. So the pH is minus log of that value, which gives you pH equals to 5.42. Okay, so the pH of that is 5.42. Right, a student plans to titrate the butanoic acid solution with a solution of ethylamine. Explain why the titration could not be done using indicator, because they're both weak, aren't they? Butanoic acid is a weak acid, ethylamine is a weak base. So an equivalence point to color change is difficult to judge because there's no color change, obviously. It goes gradually, very slowly, so you can't have an indicator that works for this one here. I hope it makes sense. Thank you.